center of the earth, we have to travel a distance of 6,378 kilometers. And what kind of interior is there inside the earth? It has to be known by few direct sources as well as indirect sources. So if we talk about the direct sources, it is very limited. Direct sources, to know the interior of the earth is very limited. Either you go for gold mines of South Africa, that is 3 to 4 kilometer deep, 3 to 4 kilometer deep. This is the gold mine, and we can directly go for mining and have some kind of interior, okay, the chemical composition, the density. So we are going to have some understanding about the chemical composition of the rock. We have idea of density of the crust, and we have also the idea about the increase in temperature, and we have the rate of increase, initial rate of increase of temperature was also known. But we are not having the understanding of entire earth, because it is a just fraction of the earth which we are going to know. Second is deep ocean drilling project. Deep ocean drilling project, which is in Kola region. It is in Arctic Russia, where boring of 12 kilometer is what, this is the maximum depth up to which human have reached, just 12 kilometer. Compare with this 6,378, it is almost negligible. So it is the maximum human endeavor up to which we have reached directly. So these are some direct what you can say evidence, but these direct evidence is not telling much about the interior of the earth. Then we started exploring indirect evidences. And in pursuit of knowing indirect evidences, we have analyzed some clue from the volcanic eruption, and this volcanic eruption is giving us the idea of the chemical composition of, let's say, magma. So there is formation of cone, and this cone is nothing but solidified magma that comes from the interior of the earth. So on the very basis of chemical analysis of this solidified magma, we have the understanding of chemical composition of magma, that may be acidic magma, or maybe basic magma. We have the understanding of density of this magma, but not much about the place of origin of magma, how deeper this magma is situated, and whatever the magma that come up is belonging to which strata of the earth. So it is not known just by having the understanding of this volcanic eruption. So again, next, what you can say indirect evidence, we go for density measurement. and the crustal density happened to be 2.57 gram per cc. This is the crustal density. That means you can measure this crustal density without any doubt. Crust तो ऊपर ही है, आपने लिया और density measure कर ली. But what happened? There was a scientist, Cavendish. He measured, he was a scientist, Cavendish. He measured the average density of the earth. He measured the average density of the earth, and that came up 5.57 gram per cc. It was the average density of the earth, and on the very basis of Newtonian principle, on the basis of Newtonian principle, this measurement was achieved, and after this very result, curiosity about the interior of the earth was also enhanced, because you have the measurement of crustal density and you happen to have a density which is average density of earth. That means when we move inside, there will be increase in density without any doubt. So whatever the composition on the crust, there will be increased composition of different chemical, different elements when we are moving inside the earth. So this endeavor led us more curiosity, infused more curiosity in pursuit of knowing the interior of the earth. So people started exploring different, what you can say, ways and means. But again, these are not going to be fruitful. Why it is not going to be fruitful? Because nothing can be spoken in entirety. Things are very fractured, and there is no such evidence which is going to tell the entire story. So we require something which can go inside and come up and will tell us the inside story. And in that case, we have reached ultimately two seismic waves. Seismic wave. So these are seismic wave which is generated due to release of seismic energy and are responsible for earthquake, responsible for earthquake. So seismic wave, fine. So seismic wave is nothing but release of energy from the interior of the earth, from any point where the seismic energy has been released. This point is called as hypocenter. This point is called as hypocenter. Fine. Hypocenter, or it is also termed as focus of the earthquake. Focus of the earthquake. Fine. Hypocenter. This is the place where the seismic energy is being released. This is the place from where earthquake starts. Release of energy takes place. Okay, and from here the energy released and it start traveling in form of body wave, which is of two type, in form of body wave which is of two type. One is primary wave, another one is secondary wave. Body wave one is primary wave. This is what body wave. Body wave in all direction. It start reaching in all direction. These are the body wave. Okay, and the point at which it is going to strike first is called as epicenter of the earthquake. Is called as epicenter of the earthquake. Fine. So two types of waves are there. One is body wave, and body wave bring the energy at epicenter, and there is redistribution of energy takes place, and this give rise to surface wave. Fine. So here energy get redistributed, and this redistribution of energy give rise to surface wave that basically travels in the skin of the earth. Surface wave that travel in the skin of the earth, that means the earth crust. So this is what called as surface wave. Surface wave. Who is responsible for surface wave? Sir, energy brought by the body wave. At epicenter, what is happening? Redistribution. Redistribution of energy. That is taking place over here. And redistribution of energy brought by body wave is responsible for genesis of surface wave, and that generates surface wave, and surface wave start traveling in the skin of the earth. Fine. So let me tell you about the body wave and surface wave. First we will take up this surface wave. Surface wave, it is of two type. One is love wave. Love wave are also called as L wave, and it was discovered by A.E.H. Love, was a mathematician. And another one is relay wave. Relay wave, or it is R wave, and it was discovered by Lord Rayleigh. Lord Rayleigh, who was a statistician. So these surface wave, it is actually generated because of a redistribution of heat, redistribution of energy brought by the body waves. Is it okay? And these surface wave are going to be disastrous. The maximum destruction in earthquake is because of surface wave. Maximum destruction in earthquake is due to these surface wave. Okay, because they create oblique motion. Oblique motion. Okay, they create oblique jerky motion. Suppose that body waves do this kind of motion, up and down motion. And what about oblique motion? Suppose that I am the building and there is oblique motion, so I start moving like this. So I am your teacher, that's why I reverse back. But what about building? It will collapse. So this is what the meaning of oblique motion. It moves just like serpent on the earth surface. Serpent on the surface. This is the reason why they are going to inflict maximum destruction due to earthquake. Maximum destruction. Is it okay? And as you move away from the epicenter, you will find destruction, in general, destruction is decreasing. Maximum destruction is taking place near epicenter. Okay. So maximum destruction is taking place near epicenter. As you move away from epicenter, destruction is going to decrease. But yes, they are also depending upon certain other factors. For example, away from epicenter, there is unconsolidated mass. Over there is a lot of population density. So unconsolidated land mass results more and more tremors. So here the destruction in terms of loss of life, loss of property will be more, isn't it? But in general, you find that the impact of earthquake is decreasing as we are moving away from epicenter in general. Okay. So this is surface wave we have discussed. Let's come to the body wave. Body wave, it is of two types. Why it is called body wave? Because it is traveling inside the body of the earth. Traveling inside the body of the earth, it is of two types. One is primary wave. अच्छा, ये रनिंग नोट्स आप बनाते चलिए, डिक्टेशन का टाइम थोड़ा कम है. So whatever I am just giving on the board, it's complete. Go ahead and make your notes out of it. Okay, so when is there anything left? Shall I go for? तो आप मुझे बताओगे. होता क्या है ना कि जब मैं पढ़ा रहा हूं तो at that very time no, you can take this as a PDF. You can take. हाँ, you can go for the PDF. ठीक है. मुझे आप बता दिया करिए कि सर अभी हुआ नहीं है. प्रीवियस स्लाइड. You people are authorized to say this. Okay. हो गया. इससे पहले का भी छूटा है क्या? चलें आगे. ठीक है. So primary wave and secondary wave. Secondary wave. In this particular topic, I will give you some more information which is not in NCERT. It is a little bit beyond the NCERT because it is need of the hour. So you must have the understanding. So primary wave, why it is primary? Because it is first to reach at epicenter. First to reach at epicenter. Why first? Because it is the fastest. The fastest seismic wave. Seismic wave. The fastest seismic wave with a speed 6 to 15 kilometer per hour. 6 to 15 kilometer per hour. Fastest seismic wave. They are mechanical, longitudinal. They are mechanical longitudinal wave. Mechanical longitudinal wave are those waves in which medium particle oscillates in the direction of wave propagation. Compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction. This is how the wave is propagating. Wave propagation is taking place like this. And here it is compression, rarefaction, compression, rarefaction. This is how the wave is moving. So there is a to and fro motion of the medium particle. Such waves are called as mechanical longitudinal wave. Along the direction of wave propagation, when medium particle oscillate, it's mechanical longitudinal wave. So this is direction of wave propagation. Wave propagation, and here it is to and fro motion of the medium particle. to and fro motion of medium particle along the direction of wave propagation. It is just like the sound wave. It is just like the sound wave. Mechanical longitudinal wave. Primary wave is just like the sound. And mind my words, whenever there is earthquake strike, you will hear a rumbling sound inside the ground. It is coming from the ground. Just below your feet, it seems as if a huge motor is moving. That rumbling sound is actually the arrival of primary wave. That is wave. So, you will hear rumbling sound. Rumbling sound just at the time of earthquake. Just at the time of earthquake. Just at the time of earthquake. अच्छा ये मिटा देता हूँ, सेकेंडरी वेव आगे देख लेंगे, है ना? Just at the time of earthquake, and this rumbling sound is because of arrival of P waves. It is because of arrival of P waves or primary waves. ठीक है? अच्छा याद आया? Primary wave is also called as P wave. Why it is called as P wave? क्यों कहते हैं इसे? हाँ? Why it is? No, it is actually pressure creating wave or push wave. Push wave, or it generate pressure creating wave. So it is the intrinsic nature of this wave that it generates pressure. अभी मैं यहाँ बोल रहा हूँ ना, तो I create pressure in the medium particle, and medium particle oscillate according to the pressure created by my voice, my sound. So this sound is going to create a pressure, and again this sound is going to create a pressure on your tympanum membrane. Accordingly your tympanum membrane vibrates, and then your mind understand in which language I am speaking right now, in which language you understand, because of that very pressure which I am creating in the medium. And this pressure is going to create vibration in your tympanum membrane. On the very basis of vibrations, brain is going to detect, isn't it? So this wave is also going to create a pressure, it create a push. So this is intrinsic nature of this wave, that's why it is called as push wave or pressure wave. Fine. P wave can pass through, it can travel in all the medium. It can pass through all the medium, whether it is solid, liquid or gas. It can pass through in all the medium, whether it is solid, liquid or gas. It can pass through in all the medium. On increasing density of the medium, velocity क्या होगी बच्चे? Velocity of P wave will increase. And due to increase in velocity, what happens? Their path get deflected. Because of variation in velocity, they are not moving on same path, it get deviated. Why this deviation? Because of change in density. change in density results change in velocity, and change in velocity results deviation in the path of the p wave. Understood? एक एक पॉइंट ध्यान रखना क्योंकि इसी को हम कनेक्ट करेंगे इंटीरियर समझते चल. So this is what the primary wave. The second which we are going to discuss is secondary wave. So let me give you idea of secondary wave. Secondary, छूटा तो नहीं बच्चे? Secondary wave. So they are second to reach at epicenter. Second to reach at epicenter. Why second? Because they are second fastest. They are second fastest seismic wave. They are second fastest seismic wave with a speed 5 to 7 kilometer per second. 5 to 7 किलोमीटर पर सेकेंड. पर आवर नहीं लिखा ना उस बार, मैं गलत तो नहीं लिखा है ना? पर सेकेंड ही लिखा है, पर आवर लिखा है. आवर लिख दिया. हाँ तो ये गलती है, मैं कर देता हूँ. पर सेकेंड है भाई. आवर होगा तो साइकिल पे बैठ के आ रहा है, अर्थ को आराम से चाय वाय पी के चलेंगे. इट इज पर सेकेंड. इट इज मुझे हाइपोसेंटर. इट इज पर सेकेंड सर, प्लीज करेक्ट. मैं लिख देता हूं और बाद में मुझे याद आता है कि पर आवर तो नहीं लिखा है. लेकिन आप बताइए ना, अगर पर आवर होता आराम से आ रहा होता, आपको पता चलता अर्थक्वेक आ रहा है, तो आप क्या कहते घर में? चाय वाय बना लो, आराम से निकलेंगे, है कि नहीं? मान लो 500 किलोमीटर से आ रहे हैं नीचे से, तो आने में 10-12 घंटे लगेंगे. तब तक आराम से चाय पी लिया, कॉफी पी ली, सो लिया, अलार्म लगा के सुबह उठे, नहा धो लिए, फिर निकले. ऐसा तो अर्थ कोई टाइम देता नहीं. तो इट्स पर सेकेंड. ठीक है. ठीक वैसे ही इट इज पर सेकेंड, 5 to 7 किलोमीटर पर सेकेंड. ठीक है बच्चे, 5 to 7 किलोमीटर पर सेकेंड. इट इज मैकेनिकल transverse wave. Mechanical transverse wave. Direction of wave propagation and oscillation of medium particle remain perpendicular So this is a kind of movement. So you will find the direction of wave propagation is like this, and the medium particle oscillates perpendicular with the direction of wave propagation. So this is the direction of wave propagation, and here it is the medium particle, up and down motion. It is just like the wave created in water body. At the surface. So जब आप कभी पानी में पत्थर फेंकते हो बच्चे, तो सरफेस पे जो वेव चल रही हैं, दैट इज व्हाट? मैकेनिकल ट्रांसवर्स वेव. फाइन. Further, it is also called as S wave. It is known as S wave. Why it is called as S wave? Why it is called as S wave? Slow? No. Its intrinsic nature is to produce stress, stress producing wave. Stress producing wave. It is a stress producing wave. So this is S comes from stress. इसका nature है बच्चे, it try to produce a stress. It try to produce a stress in the medium. Fine. And it can travel only in which medium? Solid medium. It can travel only in solid medium. Only in solid medium. In liquid medium, they cease to travel. In liquid medium, they cease to travel. They are not able to cross the liquid medium. Why they are not able to cross the liquid medium? Speed is slow. कुछ पढ़ा है आपने? क्यों? ये जरा समझाइए आप क्या बोलना चाह रहे हैं, मैं समझना चाह रहा हूँ आपके मन में क्या है। तो वही तो पूछ रहा हूँ, क्यों? हाँ, तो उससे क्या होता है? तो मीडियम तो सॉलिड मीडियम है, सॉलिड मीडियम में तो किस सॉलिड मीडियम में तो उसमें साउंड वेव तो ट्रेवल कर गया ना। क्या बात कर रहे हैं? पानी में हवा से तेज आवाज होती है। हाँ, सॉलिड में सबसे ज्यादा होती है 330 मीटर पर सेकेंड। इट इज द एयर, इनसाइड द एयर वेव मींस साउंड की जो वेलोसिटी है। वाटर में इवन मोर, बिकॉज वाटर हैज मोर डेंसिटी एज कंपेयर टू एयर। एंड स्टील में सबसे ज्यादा होती है 1150 मीटर पर सेकेंड। क्यों प्रोपगेशन नहीं होता? आप अच्छा सोच रहे हैं, लेकिन ये तो बताइए व्हाई देयर इज नो प्रोपगेशन। लेट मी एक्सप्लेन। फाइन। So what happened? There is solid medium. When there is a solid medium, this is solid medium. So when this wave is coming over here, what is wave? Wave is nothing but the flow of energy. Yes or no? So this is going to be solid medium. Solid medium, and this wave is a stress producing wave. It is associated with certain amount of energy and it tried to produce a stress. But this medium being solid is not going to be deformed. It remain intact. So there is no deformity. If you want to produce a stress and there is no deformity, energy get consumed. But if there is deformity, that means that energy get used up. For example, if I say just hit me in my stomach, और आप एक पंच मारे, I will land in गंगाराम, क्योंकि लगेगी, है ना। अब मैं कहूं कि आशीर्वाद आटे का एक बोरी ले आओ और उस आटे को क्या करो, उसका डग बना लो, and then give me, and then I say hit me as much as you can. तो क्या होगा बच्चे? आपके पंचेज आएंगे और इस आटे में लगेंगे, डिफॉर्मिटी क्रिएट होगी और सारा पंच का जो फोर्स है या एनर्जी एसोसिएटेड है वो यूज्ड अप हो गई. किस में यूज हुई? टू क्रिएट डिफॉर्मिटी. टू क्रिएट डिफॉर्मिटी. पहले ये नहीं था तो डिफॉर्मिटी नहीं क्रिएट हुई थी, एंड दिस एनर्जी ट्रांसफर्ड to the internal organ. That's why there is a problem. But what happened here? The energy get used up. Similarly, in the solid medium, the energy get conserved because no deformity is there, so it travels and it crosses the solid medium. So there is a stress, it is producing a stress, and there is no deformity. Hence, energy get conserved and wave propagates through the solid medium. Now what? There is liquid medium. This is the liquid medium. And this secondary waves are just cross the solid medium and they are reaching towards the liquid medium with same intention to create stress. And what happened? This is liquid medium, it get deformed. So there is deformity in this medium. So there is deformity in this medium, and this deformity is going to take all its energy. So whatever energy is associated with this wave is being used in creating deformity. Deformity created. Why? Because this medium is liquid. So what happened? This energy get dissipated in creating deformity. So the energy is no more there. So the wave is not going to propagate. This is what happened to secondary wave or S wave. So they are not able to cross. S wave are not able to cross liquid medium because they are stress producing wave, and in the liquid medium the stress create deformity, and in creation of this deformity the energy associated with the wave get used up, and dissipation of energy is what? Vanishing of the wave. Is it okay? So they are not able to cross the liquid medium. This is what S wave is. क्यों स्ट्रेस डालेगी? वो प्रेशर क्रिएटिंग वेव है. स्ट्रेस और प्रेशर में तो अंतर है ना जी. टेंजेंशियल फोर्स है. अब उतना साइंस मत पढ़वाओ, आप समझ रहे हो ना? नहीं एससी वर्मा, देखा जाए, है ना? सो स्ट्रेस एंड डिफॉर्मिटी. अंडरस्टूड? शैल वी प्रोसीड? ओके, आगे चलें. अब क्या होगा बच्चे? नाउ ऑन द बेसिस ऑफ these observation of seismic events, we have reached certain observation, we have reached certain results. वो results क्या थे? क्योंकि you all have this idea that seismograph is an instrument working on Richter scale that give us idea about the intensity of earthquake. Intensity of earthquake is present on the entire earth surface. Each city, each airports are going to have seismograph. Each meteorological stations are having seismograph. That means n number of seismographs are there worldwide. Fine. And the seismograph are so sensitive that it can record the very minor earthquake. Very minor earthquakes cannot be perceived. Human being to perceive ही नहीं कर सकता. Even dogs are also not able to perceive, but it can be recorded by using this seismograph. So this can record seismograph recorded by seismograph, and every year we have more than 1.5 lakh events of very minor earthquake. Very minor earthquake, जिनके लाखों इवेंट हर साल होते हैं. That means there are lakhs of data to analyze, isn't it? And on the very basis of analysis of this seismic data, what was found was shadow zone. Okay, so shadow zone were discovered. So how we reached to shadow zone? Let me explain this shadow zone to you. And the first one is P wave shadow zone. P wave shadow zone. P wave shadow zone. So this is the earth, and suppose that there is an event, seismic event have taken place here. Here it is the center of the earth. This represent the 90-degree angle, and this represent 103-degree angle, and this is 143-degree angle. 103 and 143 degree. In some book it is written 105 and 145, but ultimately the angular distance is what? Of 40 degree. So what happened? This is what? Hypocenter, and from here seismic wave start being recorded on each and every seismograph in all direction. These are the P waves that were recorded everywhere, and these P waves were recorded everywhere, but the zone between 103 and 143 P waves were not found. These are the area where P waves were absent. This is the area. No P waves were recorded. No P waves were recorded. And again beyond 143 degree, P waves were again being recorded. That means beyond 143, P waves were recorded again. So where is the P wave shadow zone? Between 103 to 143. P wave shadow zone. P wave shadow zone between 103 to 143 degree. Is it okay to everyone? Okay. And for every event, this was the outcome. Suppose that this is event E1. For event E2, let's see, this is event E2, which is taking place. Let's see, suppose that यहाँ पे हुआ seismic event. ये क्या है बच्चे? Center of the earth. And this is what? 90 degree. This is event E2. Now, event E2 that have taken place at this hypocenter. This is event E1 taking place at this hypocenter. तो यहाँ से जब seismic wave चले बच्चे चारों तरफ चले, everywhere they were recorded, being recorded. 103, 143. So 103, 143 degree. It is recorded everywhere. Everywhere it is recorded. But again, beyond what? 103, it was not being recorded. And after 143, these are further recorded. That means there is a shadow zone. Where is this shadow zone? This 103, 143 is going to be shadow zone for every event. So what is 103 and 143? This angle is with respect to hypocenter and the center. बहुत बच्चे जो ऑप्शनल के भी हैं उनसे पूछा जाए कि ये एंगल क्या है तो उनको लॉन्गिट्यूड दिखाई पड़ता है. आप कंफर्म हो जाइए. It's not longitude. It is the angle with respect to the hypocenter. ठीक है, hypocenter and the center. Fine. So you will find that every time you happen to have this shadow zone between 103 to 143 degree. Then you ask P wave, why are you not able to reach in these shadow zone every time? हाँ, क्या नहीं समझ में आया? जोन कैसे बना? आप बात कर रहे थे सर, ध्यान से देखिए। अब ये अर्थ है, ठीक है, स्फेरिकल है, अर्थक्वेक अंदर आए, जहां पे शुरू होता है अर्थक्वेक, दैट इज व्हाट, दैट इज हाइपोसेंटर। आप शुरू में नहीं आए थे क्या? ऐसे काम नहीं चलेगा सर, आपको आना पड़ेगा समय से, नहीं तो छूटेगा। ये जब बता रहा था तब थे आप, तो इसीलिए आपको नहीं समझ में आया। दिस इज द पॉइंट फ्रॉम वेयर द अर्थक्वेक हैव स्टार्टेड, एनर्जी हैज रिलीज्ड, that is called as hypocenter, and it travel in form of body wave, primary wave and secondary wave, okay, and this is reaching on to the epicenter, and this primary wave and secondary wave कहाँ से आए थे आप, ये तो बताइए। body wave, तो body wave की characteristic पढ़ी है आपने। so P wave can travel in all the medium, but S wave can only pass through solid medium, it is not going to travel in लिक्विड मीडियम। ठीक है, इतना समझ में आ गया। अब क्या हुआ बच्चे, इट वॉज रिकॉर्डेड बाई सेस्मोग्राफ, ऑल द कंट्रीज आर देयर ऑन द surface, so seismographs are placed everywhere and here and there, and there are more than 1,50,000 minor earthquake every year. That means there are data of 1,50,000 earthquake event. In all earthquake event, it was found that P wave shadow zone occurs between 103 to 143 degree. What is 103 and 143 degree? It is the angle with respect to the hypocenter and the center. It is an angle with respect to hypocenter and the center. ये earthquake, ये है बच्चे आपका earth. Inside the earth, this is, suppose that this is the hypocenter. From here the earthquake is originating. So how I'm going to draw this angle? This is going to be center, and it is 90 degree. 90 degree. Okay. And what about 103 degree? This is 103 degree. What is 143 degree? This is 143 degree. Is it okay? 103 and 143. Likewise, this side also 103 and 143. So this 103 and 143 is angle with respect to hypocenter and center. So suppose that this is E1. So this is hypocenter, and then 103 and 143 is here. अगर मान लो यहाँ अर्थक्वेक आया तो इसके हिसाब से 103 143 ये जोन होगा, लेकिन अर्थक्वेक ही यहाँ आए तो उसके हिसाब से 103 143 किधर होगा, निकालना पड़ेगा ना। आप देखें कहाँ करते हैं आप। Suppose that this is the earth and here it is the hypocenter. This will be the center. आपने ऐसे लाइन खींच ली। अब ये 90 डिग्री कैसे बनेगा बच्चे? This is 90 degree. 103. Here it is 103, 143, 103, 143. तो ये शैडो जोन हो जाएगा इस इवेंट E2 के लिए। This is shadow zone for this event E2. Is it understood? अब तो समझ में आया? कोई अभी भी है क्या महानुभाव नहीं समझ पाने वाले? समझ गए? मैंने देखा है लोगों को ये एंगल का पता नहीं होता, उनको लगता है ये लॉन्गिट्यूड है, उसको तो लैटिट्यूड भी लगने लगता है, आप क्लियर रहिएगा. So this angle is with respect to hypocenter and the center, and you always find this shadow zone between 103 to 143 degree. So when you ask this P wave ki why you are not able to reach over there, P wave will tell you somewhere 2900 kilometer below the earth surface there is enormously high density, and there is a sudden change in density that has increased my velocity almost with double, and that deviate me to pursue the original path, and I get deviated and I get deflected. Somewhere 2900 kilometer there is something which is of enormously high density, that deviates me. Who is saying this story? P waves. ये आए तो होंगे यहीं पे और जाने के लिए ऐसे और यहां पहुंचते, लेकिन they get deviated and they have reached like this. They have deviated like this. So because of this enormously high density, somewhere 2900 kilometer, ये 2900 kilometer कैसे आया? Every time there is a angular distance of 40 degree, and that give you the depth which is almost 2900 kilometer. It involves lot of calculation. Fine. So somewhere 2900 kilometer below the earth surface, there is massive change in density, massive change in density that led the deflection, and hence there is P wave shadow zone. तो P wave shadow zone ने क्या बताया कि in somewhere 2900 kilometer there is massive change in density, and that is what? Presence of core, outer core. We get to know that there is at the center there is core as well as outer core, and that is what? With very high density, and due to this high density what happened? There is deviation in the P wave, and P waves are not being recorded between 103 to 143 degree. P waves are not being recorded between 103 to 143 degree. Is it okay? नहीं. P wave and S wave both are responsible for upward and downward movement. Okay, and the surface wave is going to create these cracks and all. ना? And the cumulative effect, it's not like कि एक ही आदमी ने किया है, एक ही wave ने किया है. It's like a cumulative effect. When there is a crustal rearrangement, maybe the second time crustal rocks are not arranged in that way. So suppose that this is the strata, and there is rearrangement of the crust, so maybe this crust get upward. So यहाँ upliftment हो गया, यहाँ crack develop हो गया. So this is how it is. मत relate करिए सर, ठीक है? It is a cumulative effect, and maximum destruction, as I told you, it is because of surface wave, because of oblique motion. And oblique motion will result what? Loss of gravity, so there will be collapse of building. And what about this? Upward and downward motion. It's not going to create this, means center of gravity remain over there, so मतलब क्या कहते हैं, संतुलन, balance बना रहता है, isn't it? See, this is what P wave shadow zone, and P wave shadow zone से क्या पता चला कि there is something inside the earth which is of very high density, and you know The density of mental has the lower mental has a density of 5.5 gram per cc, but density of outer core is 11 to 12 ग्राम पर सीसी. तो जस्ट डबल डेंसिटी होती है बच्चे. लोअर मेंटल के बाद there is outer core and there is enormous change in density that has changed the velocity and hence the deviation. 2900 kilometer was estimated because of the angular distance which happened to be 40 degree always in each E1, E2, E3 and En number. N numbers are more than 1.5 lakhs. And you go for various computerized, what you can say, data analysis. Further, another one is S wave shadow zone. S wave shadow zone. So what was S wave shadow zone? Similarly, there was earthquake. This is the event E1. You know the event. So one figure is enough to make you understand. And this is the 90 degree. Okay. And this angle is 103 degree. And this angle is also 103 degree. So from here, there is release of energy, release of S wave in all direction, and it is recorded everywhere. But beyond 103 degree, there was no S wave recorded. Beyond 103 degree, there was no S wave recorded. So this is what? This entire 103, this area is S wave shadow zone. तो पूछा गया भाई कि तुम क्यों लोग नहीं आए, क्या चक्कर था? तो इसने भी क्या कहा? Somewhere 2900 kilometer below the earth's surface. मत पूछो भैया क्या हुआ, कहा वहां मिल गया था लिक्विड मीडियम, है ना? So somewhere 2900 kilometer below the earth's surface, we had confronted a medium which kind of medium? We have a medium which is liquid in nature, and as you know that we are a stress producing wave and we try to produce stress and that medium get deformed. So whatever the friends who were reaching over there, इस कलर से दिखाते, so they are reaching over there, but what happened? There is deformity that takes place over here, and then they get, the energy get dissipated. Understood? So in that case, there is no S wave that can cross this medium and there is S wave shadow zone. आपको समझ में आ गया जी? पक्का? आप कोई दिक्कत तो नहीं बच्चे? आप मतलब चेहरा आपका वो हंसमुख नहीं लग रहा? अच्छा, मतलब मुझे लगा कि कोई दिक्कत तो नहीं. Everything is all right. Everyone is syncing with the information. और थोड़ी बहुत डांट पड़ जाए ना तो परेशान मत होना, कभी कभी डांट देता हूँ क्योंकि मुझे लगता है कि आपको सब कुछ जानना चाहिए. So you people become special when you are in the class. कल जब बूढ़े हो जाएंगे हम लोग तो तुम ही लोग तो संभालोगे. और बैटन आगे ट्रांसफर कौन करेगा? तो इसलिए जरूरी है, समय से आइए, पे अटेंशन, whatever is given, please have it and resolve all your queries, और जाओ तोड़ दो, और क्या, समझ गए, जीत के आओ। ठीक है, ये है बच्चे एस वेव शेडो जोन। समवेयर 2900 किलोमीटर बिलो द अर्थ सरफेस देयर एग्जिस्ट a liquid medium, that's why we are not able to reach over here beyond 103. So S wave shadow zone ने क्या बताया बच्चे कि outer core is liquid. So liquid nature of outer core, it was established from S wave shadow zone. So these were the findings, and on the very basis of these findings, and there are many tomographical scan, many what you can say data analysis, the data which is from seismic wave was analyzed by using computer, and we have deduced the interior of the earth, which is going to be there the next topic. So on the very basis of S wave shadow zone, P wave shadow zone, we have a nutshell understanding, and the model of Earth's interior is what? Deduced. You understand what is the meaning of deduced model? Deduced model का मतलब ये होता है बच्चे कि on the very basis of observation you are linking the story and creating the entire event, है ना? तो इंटीरियर, अर्थ के इंटीरियर की भी जो स्टोरी सामने आई ऑब्जर्वेशन के आधार पे, उसको एक साथ जोड़ा गया और अर्थ का मॉडल तैयार किया गया। समय समय पे कुछ डिस्कवरीज होती रहीं, उन डिस्कवरीज में किसी को कुछ डिसकंटिन्यूटीज मिली, कुछ क्या कहते हैं एनामली दिखाई पड़ी, देयर इज अ वेरिएशन इन वेलोसिटी, सडन इंक्रीज or something like that. So there are certain discontinuities which came into existence time to time. Means we are knowing that these kind of discontinuities or sudden change in density occurs inside the earth. So we have Mohovisic discontinuity, Gutenberg discontinuity, Rapiti, Conard, Lehman discontinuity. So with time, as the technological upgradation was going on and the discoveries were going on, these discontinuities were known. So on the very basis of these data analysis and observation, interior of the earth was established, and how it looks like I'm just going to explain. You just use the entire page for making the figure which I am going to draw. This will be elaborative, what you can say, figure containing all the information which is required for your UPSC preparation. इस एक पेज से ही पूरे अर्थ के इंटीरियर का रिवीजन भी हो जाएगा। तो पूरा एक पेज आप लें और उस पे बनाना शुरू करें, जो मैं ड्रॉ करने जा रहा हूं। क्या हुआ? बेटे सारे अर्थ को बताया, तो सेस्मोग्राफ क्या कर रहे हैं बैठ के? मैंने यही तो बताया, तो वेरी माइनर अर्थक्वेक एवरी ईयर, यू हैपन टू हैव मोर देन 1.5 लाख अर्थक्वेक एवरी ईयर, so you need not to generate it, it is already there. मैनुअली भेजने की जरूरत नहीं है, एवरी अरे भाई एक्सीडेंट नहीं है, वेरी माइनर अर्थक्वेक आप अभी आ चुका है, 10 आपके बैठे बैठे आ चुका है सवाल पूछने के बाद। 1,50,000 मोर देन अर्थक्वेक इन 1 ईयर। आप इमेजिन करें रोज कितने अर्थक्वेक आ रहे हैं, 365 डेज में मोर देन 1,50,000। यस, ऑब्जर्वेशन, ठीक है। and it's not so easy, whatever we are going through is general study. जियोलॉजी में कैसे पता करते हैं, कौन कौन से तरीके अपनाए जाते हैं, कहीं ट्रायंगुलेशन करते हैं, ट्राइलेटरेशन करते हैं, तो वो आपके सब्जेक्ट का पार्ट है नहीं, ठीक है। टोमोग्राफिक स्कैन कैसे करते हैं, कैसे उसको स्टडी करते हैं, दैट इज नॉट द पार्ट ऑफ योर सब्जेक्ट। It is the understanding of general study. It's not a specialized class. Do remember, I'm your geography teacher, not a geologist. ठीक है? जैसे क्वेश्चन आप पूछे ना, जो आपके समझ में ना आया हो वो क्वेश्चन पूछे, उसका जवाब मिलेगा. But the thing is, what is the process, what kind of technology was implied, how the calculation was made, what kind of formula was used, what a kind of means there is calibration done first, then standard were made. आपने अगर रिसर्च की है तो आपको पता होगा कि तुरंत आपको तो रिजल्ट्स मिलते नहीं. You go for multiple observation, then you conclude that these are the things which happen every time. So there is certainly there is a conclusive what you can say finding. तो वो सारी चीजें हम थोड़ी यहाँ पढ़ने पढ़ाने के लिए बैठे हुए हैं. आप समझ पा रहे हैं? आपको बताया गया मल्टीपल रिपीट्स आर देयर. Replicates are what? 1,50,000 replicate every year. तो आपके पास 10 साल में कितने replicate हो गए? 15 lakh replicate. Go for various replicate. In each replicate, your S wave shadow zone is there, P wave shadow zone is there. So you need not to create this S wave. This S wave is what? Just the record of the seismograph everywhere. North America, different cities are having different airports, meteorological stations. Can you imagine how many numbers of seismographs are there? Okay, so worldwide the seismograph is giving you the data, and then you go for calculations. Then you go for superimposing all those calculations and then find out the outcome. It's not as easy as it seems to be. Okay, so multiple data analysis. Fine. And do remember, whenever, even in your science and technology, if I am saying that there is transgenic animal or BT cotton was created, so you need not to worry about how this gene was identified, how DNA was isolated, how molecular Caesar is going to cut it, इलेक्ट्रोफोरेसिस कैसे किया. ये पार्ट रिसर्च का है सर. आपको जानना है व्हाट इज ट्रांसजेनिक प्लांट और ट्रांसजेनिक एनिमल एंड व्हाट आर द सिग्निफिकेंस, वेदर इट इज गुड और बैड. सो वो नटशेल आपको चाहिए. नीड नॉट टू वरी अबाउट द टेक्नोलॉजी. ये वर्चुअल रियलिटी कैसे क्रिएट करनी है सर, कंप्यूटर कैसे बनाना है, क्वांटम कंप्यूटर कैसे बनाना है. क्वांटम कंप्यूटर वो आपसे थोड़ी बनवाएंगे, वो उसे एडमिनिस्ट्रेशन कराना है आपसे. मेरी बात समझ पा रहे हैं ना? So the class is what? For general study. Purpose is for general study. Making the NCERT a little bit lucid for you. Making it what? Understandable. Because you all have gone through S wave shadow zone, P wave shadow zone. Most of you is not deciphering what is the angle, how this angle is measured. ये मेरी हालत थी तो मैं क्या ही बताऊं. मैं कई दिन तक मुझे लगता था ये क्या है यार, लॉन्गिट्यूड है कि लैटिट्यूड है. And no teacher was telling us. Because I have felt all these difficulties during my preparation. तो मुझे लगता है कि ये सारी difficulties आपको ना आए. Isn't it? So that is what the purpose. So n number of data analysis was there, and then the interior of earth was deduced, and there is crust, upper crust, upper crust, which is the first layer of the earth, upper crust, followed by lower crust, lower crust, upper crust and lower crust. Upper crust is made up of silica, aluminium, and lower crust is made up of silica, magnesium. That is what SEMA. And this crust is also can be divided into oceanic crust as well as continental crust. The average thickness of continental crust is going to be 30-35 kilometers, while the average thickness of oceanic crust is just 5 to 8 kilometers. 5 to 8 kilometers. Fine. Oceanic crust is thinner and continental crust is thicker. Density of upper crust is 2.57 gram per cc, while density of lower crust is 3 gram per cc. Why this density difference is there? Because it is made up of silica and magnesium, and that is made up of silica and aluminum. Is it okay? Further, the continental crust, this is continental crust, average thickness is 35 kilometer. Average thickness is 35 kilometer, but sometime this crustal thickness may reach up to 100 kilometer. And mostly it occurs below the folded mountains. जहाँ folded mountain है ना, उसके नीचे crust की thickness क्या है? More than 100 kilometer. 100 kilometer भी हो सकती है. जैसे हिमालय. Below Himalaya, the crustal thickness is more than 70 kilometer. It's quite thick. Himalaya is at destructive plate boundary. This destructive plate boundary will be introduced to you when we discuss the plate tectonics. Despite of being a destructive plate boundary where the characteristic feature is volcanic eruption, Himalaya do not have any volcanic eruption. There is no volcanic eruptions in Himalayas. Why? Because crustal thickness is so thick, it is more than 70 kilometer, doesn't allow any magma to come up. That's why despite of having destructive plate boundary, Himalaya do not have volcanic eruption, just because of the crustal thickness. Is it okay? So this thickness is more just below the folded mountain series like Andes, Rockies, Ural, Aravalli, Himalaya, Alps, Caucasus, Taurus, Kulnul, Tian Shan. These all are what folded mountain, where you will find continental thickness is what? More than, means 35 is in general, it's what, quite thicker. Is it okay? Fine. And density of oceanic crust is more as compared to continental crust. So which one is more denser? Oceanic crust. Why it is more denser? Presence of magnesium. तो मैग्नीशियम के कारण या कुछ और भी है बच्चे? ध्यान से देखो तो अपर क्रस्ट कितना थिन है. So contribution of Sial is very less, and oceanic crust is largely made up of Sima. You are right, presence of magnesium, but what kind of composition is there? Sial is very thin and Sima is thick. And what about continental crust? Sial is more and Sima is less. So this figure is satiating all your requirement. Continental crust, oceanic crust, which is denser, why denser, I have discussed, which is thicker. And whenever two crust, one is oceanic and continental, going to collide, what happened? Denser plate subduct below the less denser plate. Fine. So this is the story of crust, and just after the crust there is a zone which is called as mantle. इसके बाद है mantle, है ना बच्चे? Mantle, and we can divide mantle into two parts, that is upper mantle and lower mantle. Fine, upper mantle and lower mantle. The upper part of upper mantle is solid and it is integrated with the crust. Upper part of upper mantle, which is quite solid and it is integrated with the crust. बना लें upper part of upper mantle. किस कलर से दिखाया जाए? Let me show you with yellow. This is the upper part of upper mantle. Upper part of upper mantle, which is solid in nature, and it is associated with crust. This yellow wala part, and collectively it constitute the crust, that means upper mantle, and the crust, that means upper crust, lower crust, and part of upper mantle, this much, constituting lithosphere. This is called as lithosphere. This is called as lithosphere. तो lithosphere क्या क्या है बच्चे? Upper crust, lower crust, and part of upper mantle. याद रखिएगा. And this lithosphere constitute plate, crustal plate जिसको आप कहते हैं. So crustal plate is also containing upper part of upper mantle. Is it fine? Okay. So there is a discontinuity between upper crust and lower crust. What is the name of this discontinuity? Upper crust and lower crust, यही तो होगा discontinuity का zone. ये green से जो बना रहा हूं बच्चे. There is a discontinuity between upper crust and lower crust. This is the discontinuity. Discontinuity between upper crust and lower crust. This is called as Conard discontinuity. Conard discontinuity, where it is situated? In between upper crust and lower crust. Upper crust and lower crust. Conard discontinuity. बना रहे हैं कि नहीं आप लोग? फिर तो बहुत टाइम लग जाएगा. बनाते भी चलिए. अच्छा, पीडीएफ से कोई नहीं बना रहा? बनाओ, प्रैक्टिस होनी चाहिए. ठीक है, थोड़ा टाइम ही लगेगा ना. So there is Conard discontinuity. This discontinuity is present in between upper crust and lower crust. And another discontinuity which is present between crust and mantle. What is that? Mohovisic discontinuity. तो crust और mantle कहाँ मिल रहे हैं बच्चे, जरा सोच के बताओ तो. देखो, ये पीला वाला पार्ट किसका है? मेंटल का है ना, और उसके ऊपर क्रस्ट है. इसका मतलब मोहोर्विसिक डिसकंटिन्यूटी बिटवीन क्रस्ट एंड मेंटल. सो व्हाट शुड बी द बाउंड्री? शैल आई ड्रॉ इट? देखो किस कलर से बनाऊं. ब्लैक चलेगा? हाँ, ब्लैक चलेगा. सो you'll find this, there is a discontinuity that is called as Mohovisic discontinuity. Mohovisic discontinuity, that is between crust and mantle. That is between crust and mantle. So this is what Mohovisic discontinuity. Moho discontinuity. Is it fine? Mohovisic discontinuity. Mohovisic discontinuity. Moho discontinuity. Mohovisic discontinuity or Moho discontinuity. Fine. Mohovisic discontinuity. Is it okay? So Mohovisic discontinuity is present between crust and mantle. Is it fine? Acha, just below the lithosphere there is a zone of plastic mantle, and that is called as asthenosphere. This is what asthenosphere. Asthenosphere is the powerhouse of the earth movement, crustal movement. It is the powerhouse that gives power to volcanic eruptions. It is the home of magma. So this is what called as asthenosphere. So asthenosphere is part of what? Upper mantle. Up to how much depth? From the surface to 400 kilometer. There lies the lithosphere and asthenosphere. Asthenosphere is a plastic layer. बहुत सारे बच्चों को लगता है it is liquid in nature. No, it's solid. It is plastic layer over which the lithosphere slides. Asthenosphere. This one is asthenosphere. This is asthenosphere. And above asthenosphere, lithosphere floats. So crustal plate, in plate tectonics, when we discuss, this plate is moving on the asthenosphere. Asthenosphere is called as powerhouse of earth. Powerhouse of the earth. Powerhouse of the earth. Is it okay? Powerhouse of the earth. Asthenosphere, what is the depth of asthenosphere? Up to 400 kilometer. And then we have upper mantle. The temperature of asthenosphere is how much? 900 to 1200 degree centigrade. This is the temperature of asthenosphere. And what is the density of asthenosphere? It remains 3.5 gram per cc. Fine. And then you will find this upper mantle, and in upper mantle again you will find temperature of, let's say, 1200 degree centigrade. This is lower mantle, and lower mantle the temperature is having 2200 degree centigrade. And the change in density you will see over here is from 3.5 gram per cc to 5.5 gram per cc. This is going to be the change in density. Fine. Temperature from 900 to 1200 degree centigrade to 2200 degree centigrade. And largely it is made up of Mg and Fe. Mg and Fe. Upper mantle and lower mantle has a discontinuity, and this discontinuity is called as rapidity discontinuity. You will find rapidity discontinuity over here. Rapidity discontinuity. Rapidity discontinuity. Rapidity discontinuity is in between which layer? Upper mantle or outer mantle and lower mantle. This is called as rapidity discontinuity. Rapidity discontinuity, okay, which is between upper mantle and lower mantle. And this is what the depth that represent 2900 kilometer. 2900 kilometer. Beyond this, we have outer core. There is outer core. Outer core. There is outer core. Up to what depth? From 2900 to 5150 kilometer. This is outer core, and this outer core is in liquid state. it is in liquid state, and there is an increase in density of outer core. You will find this increase is 5.5 gram per cc. Just in outer core, it is going to be 11 to 12 gram per cc, and it is made up of Fe, nickel and iron, 96% iron and some amount of nickel, with a very high temperature of 4000 degree centigrade. 4000 degree centigrade. Is it okay? This is outer core. Outer core. And there is a discontinuity between outer core and inner mantle, and that is called as Gutenberg discontinuity. You have another discontinuity which is called as Gutenberg discontinuity. This is Gutenberg discontinuity. Gutenberg discontinuity. Fine. Gutenberg discontinuity between outer core and mantle. Is it fine? And remember one thing, inside the mantle, some rocks are more conducting. They conduct heat rapidly as compared to other rock. So those rock create a connection between outer core and asthenosphere, and there is lot of heat get conducted through that very path, and results pluming of magma inside asthenosphere. So you will find that there are certain rock in the mantle, they conduct more heat as compared to other rock, and this connection is going to create a zone inside the asthenosphere which is having enormously high temperature. So in asthenosphere, normally the temperature is of the range, let's say 900 degrees centigrade to 1200 degrees centigrade. But these are the hot spot where the temperature may reach up to how much? 2000 degrees centigrade. And not only heating effect, but also the molten rock of mantle is also coming over here in form of magma. And these are called as mantle plumes. These mantle plumes are present in which region? In asthenosphere. These mantle plumes are present in asthenosphere, and it is having enormously high temperature of the range 2000 degrees centigrade. And this temperature is because of the heating effect, conduction of heat from outer core to asthenosphere. Outer core कितना है? बहुत ज़्यादा heated है. So these are the more conducting rocks. So it conducts heat faster than the other part of mantle. So the heat is reaching rapidly up to this hot spots, and they are referred as hot spot, है ना? इनको क्या कहा जाता है? They are hot spot. Who said this hot spot? Mr. James Tuzo Wilson. He discovered and he gave this concept of hot spot in the year 1963. James Tuzo Wilson, that there are hot spot in asthenosphere, and they are not going to change their place, but there is continuous effusion of magma taking place, and this magma comes out onto the surface of the earth, creating volcanic eruption. Hot spot. ठीक है बच्चे? So this is hot spot, that is what? Very high temperature, and there is pluming of magma also, and hence it is also referred as mantle plume. This is also referred as mantle plume. Also referred as mantle plume. How this pluming takes place? Because of conducting rocks in metal. समझ लीजिएगा. There are certain rock which is more conducting as compared to other. So more conducting rock create a pathway through which maybe it is not as straight as I am showing, but yes, it is a pathway through which the heat is coming up. And when heat is coming up, so upper mantle के rock को क्या किया? Melt कर दिया. नीचे वाले rock को तो नहीं कर पाएगा melt क्योंकि pressure है ना, लेकिन upper rock get melted and it comes out in form of mushroom shape plume of magma, that is called as mantle plume. And these areas are having enormously high temperature. In general, the temperature is how much? 900 to 1200 degrees centigrade. The temperature of Benioff zone is 900 to 1200 degrees centigrade, but these are the hot spot representing enormously high temperature. And these hot spot on entire earth, inside entire earth asthenosphere, they are only 40 to 50, scattered here and there. Volcanic eruptions, yes. For example, Hawaii Island, Mount Kilauea, Mount Mauna Loa, Mauna Kea, Reunion Island. This is what hot spot. Mount Sidley, Mount Erebus, hot spots. Okay. So these are what? Zone of volcanic eruption. Like Yellowstone National Park in United States of America, that is also having geyser, hot spot. Fine. So these hot spot, and then there is core up to the center of the earth. We have this core. Core is made up of iron as well as nickel, iron and nickel. From 5150 kilometer to the center of the earth 6378 kilometer, we have this core area, this core which is made up of iron and nickel with a density that is 12 to 13 gram per cc and with a temperature approximately 5300 degree centigrade. So कुछ किताब में 55 लिखा है, कुछ में इमोशन में बह के 6000 भी लिख दिए हैं, तो मार्केट में यही है 5300 degree centigrade and it is solid in nature. The core is solid and there is another discontinuity in between core and mantle, and that is called as, क्या कहते हैं इसको? Lehman discontinuity. Lehman discontinuity. Lehman discontinuity. So Lehman discontinuity in between core and outer core. Fine. Core and outer core made up of iron and nickel. Outer core being at 4000 degree centigrade become liquid. तो इतने टेम्परेचर पे लिक्विड होना लाजमी है. It's very high temperature. At this very temperature, even iron and nickel is going to be in liquid state, molten state. So outer core molten state में है, and I also talked about this churning of outer core and electromagnetic induction and production of magnetosphere around the earth. So because of rotation and churning of outer core, the churning results electromagnetic induction because of liquid nature of outer core. But एक चीज नहीं समझ में आई बच्चे कि core is having more temperature but it is in solid state. Why? Means even higher temperature, even then it is in solid state. It is not in liquid state. होना तो चाहिए था इसको भी लिक्विड में, लेकिन नहीं रहता. Why? आपकी एनसीईआरटी में लिखा है बिकॉज ऑफ सुपर इनकम्बेंट प्रेशर. super incumbent pressure of outer core, mantle and the crust so enormous that doesn't allow core to be in liquid state. Because liquid state में रहने के लिए क्या चाहिए बच्चे? Intermolecular space ज्यादा होना चाहिए. But the thing is, the gravity is super, means the pressure, it exert massive pressure that molecules not able to move away from each other. And there is only one state possible for the core to be in solid state because of superincumbent gravity. It want to be in liquid state, but उसके पास वो लग्जरी नहीं है कि तुम लिक्विड स्टेट में रहो. जैसे बाकी लोग मूवी देखने जाते हैं, बट आपके पास थोड़ी उससे कम लग्जरी है ना. यू हैव टू बी सॉलिड, क्योंकि आपने सपना ऐसा देख लिया है. आर यू गेटिंग माई पॉइंट? सो एवरीवन इज हैविंग सम काइंड ऑफ लग्जरी, लेकिन आपको सॉलिड ही बना रहना है भाई. Is it okay? So this is the description which is required for you to understand. And role of hotspot, I will little bit elaborate, but I want a few notes in dictation form. You just go ahead. So please take down crust. ये clear हो गया? यहाँ किसी को नए पैटर्न को हाउ कम वी एंड यू डिसाइड ऑन द बेसिस ऑफ जस्ट 10 years क्वेश्चन पेपर? हाँ तो पढ़ना पड़ेगा. कल को अगर इससे पढ़ने लगे तो छोड़ देंगे आप. फिर वही कोचिंग वाला हिसाब आप अपनाएंगे कि जब कोई क्वेश्चन आए तो फिर पढ़ाना शुरू करो. इफ इट इज डिफाइंड सिलेबस, सो व्हाई यू आर मींस थिंकिंग अबाउट दैट आई शुड नॉट गो फॉर इट? आप ही खुद बताओ ना. आपके हिसाब से यूपीएससी थोड़ी क्वेश्चन पूछेगी. द थिंग इज, इफ इट इज, क्यों आप ये तीसरी बार पूछ रहे हैं मुझसे? चौथी बार मुझे मतलब आपका मन करे पढ़ने का पढ़ें, नहीं तो मत पढ़ें. रीजन बीइंग कि इफ दे हैव डिफाइंड द सिलेबस, ट्राई टू अंडरस्टैंड. अभी आप बच्चे हैं शायद, इसलिए उस चीज को सोच नहीं पा रहे हैं. इफ दे हैव अ डिफाइंड सिलेबस, so if you are not completing the syllabus, so how come you understand where is plate tectonics, how the plate movement is taking place? तो अगर आपको एस्थेनोस्फीयर का अता पता नहीं है, मैग्मा कहाँ बनता है यही नहीं जानते, तो फिर कैसे पढ़ पाएंगे कि प्लेट टेक्टोनिक्स क्या है? मेंटल प्लूम आया हुआ है मेंस में, कौन लिखेगा? जो जानेगा वो लिखेगा. तो ऐसा नहीं है कि यहाँ पे आपको ऐसी चीजें पढ़ाई जा रही हैं जो मतलब क्यों पढ़ाई जा रही हैं, पर्पस क्या है? 10-15 साल का जो एक्सपीरियंस है वो क्यों है? जस्ट टू मेक यू अंडरस्टैंड कि इफ दे आर आस्किंग क्वेश्चन यू कैन राइट इट इन बेटर वे. इज इट ओके? सो ट्राई टू सी द PYQs. अब मत पूछेगा आप कि ये क्यों पढ़ा जाए सर, क्योंकि पढ़ना है. कल को वो पूछेंगे सवाल तो आप क्या करोगे? हाउ कम यू अंडरस्टैंड कि व्हाट इज प्लेट टेक्टोनिक्स, वेयर इज एस्थेनोस्फीयर, where magma formation takes place, why magma formation takes place in Benioff zone. आप बहुत लोगों को यही कंफ्यूजन रहता है कि एस्थेनोस्फीयर लिक्विड स्टेट में है. अगर एस्थेनोस्फीयर लिक्विड स्टेट में होता तो शैडो जोन, एस वेव शैडो जोन और पहले बन गए होते कि नहीं? एस्थेनोस्फीयर और लिथोस्फीयर बना है अपर क्रस्ट, लोअर क्रस्ट एंड अपर पार्ट ऑफ अपर मेंटल. That is what lithosphere. Again I repeat, please mark it important. Upper crust, then lower crust, upper part of upper mantle, and then upper part of upper mantle also constitute asthenosphere. Is it okay? But asthenosphere layer of mantle is plastic in nature, over which the lithosphere floats. ठीक है? तो याद रखिएगा, आपको जो चीजें बताई जा रही हैं, इट्स अ कॉन्सेप्ट बिल्डिंग, because they are putting you in a trouble by asking question in form of statements. और statements लोगों से हिलते नहीं हैं जो कायदे से नहीं पढ़ते. तो ये तो बेसिक रिक्वायरमेंट है सर. सोच लीजिए, विचार लीजिए पहले ही, यूपीएससी का एग्जाम आसान नहीं है। इट्स अ रोलर कोस्टर राइड। आपको पढ़ना पड़ेगा, थॉरो स्टडी करनी पड़ेगी, शॉर्टकट इसका कोई नहीं है, और शॉर्टकट जो भी अपनाना चाहता है वो थोड़ा बहुत शॉर्ट पड़ जाता है। ये पुराने एक्सपीरियंस है, मैंने देखा है IITians को यहाँ फेल होते हुए और BA 3rd डिवीजन पास को क्वालिफाई करते हुए। दिस इज प्योर कंसिस्टेंसी, हार्ड वर्क, एंड दैट इज व्हाट स्मार्ट वर्क आल्सो। बट ये आप सोचें कि ये ना पढ़ना पड़े, ऐसा नहीं होगा सर। और जो चीजें आपको बताई जाएंगी दैट इज पार्ट ऑफ सिलेबस, ठीक है। सो इंटीरियर ऑफ अर्थ से जाके देखिए कितने सवाल आए हुए, और सवाल नहीं आए हैं तो दिस इज व्हाट कॉन्सेप्ट बिल्डिंग। द नेक्स्ट टॉपिक आर व्हाट वेरी मच रिलेटेड विद दिस कॉन्सेप्ट बिल्डिंग। बताइए ना मेंटल प्लूम क्या लिखते हैं? मेरी बात समझ पा रहे हैं? Hotspots, and you know this significance of hotspot. If I say where is Reunion Island, can you find out for me Reunion Island? Have you atlas? You are ready with your atlas? nahi? This is Madagascar, Madagascar, or it is called as Malagasy earlier. Here it is India. Fine. You will find there is a island east to Madagascar that is called as Reunion Island. Reunion Island. It's a French overseas territory. सो फ्रांस का ये ओवरसीज टेरिटरी है। अक्सर न्यूज में रहता है, न्यूज में इसलिए रहता है कि व्हेन एवर फ्रांस एंड इंडिया अंडरगोइंग नेवल एक्सरसाइज, देयर इज द प्लेस व्हिच इज रीयूनियन आइलैंड। फ्रेंच ओवरसीज टेरिटरी है बच्चे, एंड दिस इज आल्सो अ हॉट स्पॉट, also a hot spot. And you know Deccan Trap? Where is Deccan Trap? Deccan lava flow? It is situated in India. Deccan Trap is here. गुजरात से शुरू होता है बच्चे, जबलपुर तक जाइए और फिर आ जाइए तमिलनाडु, आंध्र प्रदेश, most of Maharashtra and Gujarat. This part is called as Deccan Trap. Deccan Trap is what? It's a lava flow, Deccan lava flow. It is made up of basalt. It's a black, going to create black cotton soil and cotton producing belt. इसी को आप क्या कहते हैं बच्चे? Deccan Trap. It's a volcanic eruption, and this volcanic eruption is from Reunion Island. कितना दूर है आप देख पा रहे हो? Thousands of miles away from here. This Deccan Trap is the outcome of this Reunion Island, and it was formed when India was just above the Reunion Island. Reunion Island is in asthenosphere, it's a hot spot. An Indian plate is moving like this, and when Indian plate is coming above the Reunion Island, Reunion lava flow is continuous there, and this has given the Deccan lava flow. You understand? So how come this concept will be understood by you if you don't know that hot spots are not going to change their location while the crust is moving? Crust is dynamic. तो जब तक जानोगे नहीं बच्चे तो कैसे बताओगे इन चीजों? So whenever I speak something in the class, आपको अभी पढ़ते तैयारी करते 2 महीने, 6 महीने या 1 साल हुए होंगे, या ज्यादा से ज्यादा 2 साल, जिसमें आपने हो सकता है PYQs देख लिए। हम लोगों की जिंदगी इसी में चली गई। सो जो कॉन्सेप्ट बिल्डिंग है वो तो करना ही पड़ेगा सर, और कॉन्सेप्ट बिना पढ़ाए ऐसे थोड़ी पढ़ा देंगे कि ये क्वेश्चन आ रहा है ये चले जाइए. इट्स नॉट लाइक मल्टीपल चॉइस क्वेश्चन वन डे एग्जाम, इट्स नॉट लाइक दैट. It's not only fact file. They are going to put you in the trouble by asking the core concept, and that too very easy concept. But if you are missing something, for example, you know earth rotation. I discussed this. Just solve one question. Just solve one question now. Mr. X is moving from point A to almost 400 kilometer towards west, and he reached at B. Mr. X from A to B 400 kilometer. Then he turned towards his right and moved for 300 kilometer, and ultimately he reached at North Pole. At North Pole. Fine. सबको समझ में आ गया? At North Pole. Okay. इतना तो समझ में आ रहा है ना? So if I ask what is the distance traveled by Mr. X? 400 plus 300, it is going to be 700 kilometer. This is one day exam. I'm just differentiating one day exam from UPSC. Okay. Don't feel derogatory. If I ask to you what will be the displacement, then you go for Bodhayan Pythagoras and you will calculate it is 500 kilometer. अब यूपीएससी यहां से पूछना शुरू करता है, कहता है कि मिस्टर एक्स when he reached at North Pole turned towards his right. Turn towards his right. In which direction he is moving? ऑप्शन है A towards east, B towards north east, C towards let's say west, D ले लो चलो towards south. In which direction he is moving? बताओ बताओ सर, फिर से रिपीट करें. ए से बी चले 400 किलोमीटर. अब आप ही बताओ ना किस डायरेक्शन से. ये तो कॉमन सेंस है यार. आप यहाँ पे हो, ये नॉर्थ है, ये साउथ है, ये ईस्ट है या वेस्ट है. वैसे आप यूपीएससी के पेपर को क्वेश्चन नहीं करते कि सर एक्सप्लेन करिए, यू जस्ट सॉल्व इट, दैट्स इट. सो थिंक ओवर हियर एंड दिस इज पॉइंट ए. फ्रॉम हियर यू स्टार्टेड 400 किलोमीटर ड्यू वेस्ट, then you turn towards your right, and after covering 300 kilometer you reached at North Pole, and then you turn towards your right. In which direction you are moving? Tell me. East. बताइए सर. आप कर लीजिए, टेक टाइम. वेक्टर एनालिसिस कर लीजिए. फिजिक्स वाले हैं ना आप? हाँ, साइंस वाले हैं ना? करिए. क्या चीज? नॉर्थ ईस्ट. नॉर्थ ईस्ट. आज इसी में टाइम चला गया. अब दोबारा आप मत कहिएगा कि सर क्या ये पढ़ाया जाए, ये क्या रिसेंट ट्रेंड को देख के. ये सारे बोगस क्वेश्चन मैं क्लास में मुझे बर्दाश्त नहीं होते. रीजन बीइंग कि आप अभी शुरू किए हैं, हम लोग खत्म करके आ चुके हैं. ट्रेंड चेंज होते हैं बच्चे, मेरी बात सुन लीजिए. सो वेन एवर दे आर पुटिंग यू इन सम ट्रबल, इन कॉन्सेप्चुअल क्लैरिटी इज रिक्वायर्ड. तो पढ़ना तो पड़ेगा सर. आंसर है इसका साउथ. कोई सोच पाया था? The answer, the right answer is south. You are at North Pole. Try to see, this is your globe. Fine, you started from here, 400 kilometer, 300 kilometer, you reached on North Pole. Now you are moving either forward, backward, or right, or left. You are moving in one direction, and that is what? South. ये है यूपीएससी। ऐसे हल्के में मत ले लो। देखो कितना सिंपल क्वेश्चन था, फिजिक्स की वेक्टर एनालिसिस चली गई। आर यू गेटिंग माय पॉइंट? सो इट्स नॉट जस्ट किडिंग ना, ये मैं बताना चाह रहा हूं, बड़े सिंपल से सवाल होते हैं उनके, बेस्ड ऑन कॉन्सेप्ट, एंड इफ यू आर मिसिंग द कॉन्सेप्ट यू आर गोइंग इन रॉन्ग डायरेक्शन। पक्की बात है, गलत करोगे, इसलिए कंसेप्चुअल क्लैरिटी जरूरी है। व्हाई आई एम पुटिंग सो मच ऑफ एफर्ट? पर्पस इज जस्ट टू मेक यू अंडरस्टैंड द कॉन्सेप्ट्स। आपने देखा अभी बिग बैंग थियरी वी हैव लर्न, आपकी एनसीईआरटी में कितना कम था, और क्या क्या चीजें आपने पढ़ी? पूरे 6 घंटे जा चुके हैं सर, जस्ट टू मेक यू अंडरस्टैंड व्हाट आर द थिंग्स। सो डोंट क्वेश्चन अबाउट कि ये पढ़ना है कि नहीं। रिसेंट ट्रेंड क्या होता है? ट्रेंड तो बदलते रहते हैं वो, और जब बदलते हैं तो लोग वो पढ़ाना शुरू करते हैं। मेरा कहना है आप सब पढ़ के जाओ ना सारा सिलेबस, फिर देखो तुम नहीं रुकोगे कहीं, no one will going to stop. So you understand why answer is south. North pole there is one direction possible, that is south, and south pole there is one direction possible, that is north. Anywhere you are moving to due south. If you are on north pole, moving due north. If you are on south pole, that's it. समझ गए? तो याद रखिएगा। चलिए आइए नोट कर लेते हैं। डेक्कन ट्रैप किससे बना है बच्चे? रीयूनियन लावा फ्लो। व्हेन इंडियन प्लेट वाज देयर, लिखिए क्रस्ट, शॉर्ट में लिखिए अपर क्रस्ट। अपर क्रस्ट made up of silica aluminium having average density 2.7 gram per cc, five seven gram per cc. Lower crust made up of silica and magnesium with average density 3 gram per cc. Magnesium, silica, magnesium 3.0 gram per cc. Crust can be divided into oceanic and continental. Average thickness of continental crust is 30-35 kilometer, while oceanic crust is 5 to 8 kilometer. Oceanic crust is denser as compared to continental crust, because क्या लिखना चाहिए? Largely made up of lower crust, because it is largely made up of lower crust. There is a discontinuity present between upper crust and lower crust. That is Conard discontinuity. Conard discontinuity. ठीक है, अब अगला लेयर है बच्चे मेंटल. हेडिंग डाल लीजिए मेंटल. which is made up of magnesium and iron. Made up of magnesium and iron. Magnesium and iron. You can divide it into upper crust, upper mantle and lower mantle. Upper mantle and lower mantle. There is a discontinuity between upper mantle and lower mantle, and that is what? Rapidity. Rapidity. Discontinuity. Rapidity, discontinuity. Further you can write upper part of upper mantle. Upper part of upper mantle is associated with lower crust. Lower crust constituting lithosphere. Constituting lithosphere. पेन चाहिए क्या? Constituting lithosphere. Just below the lithosphere, there exists a plastic layer. There exists a plastic layer that is called as asthenosphere. Asthenosphere. This asthenosphere is called as powerhouse of Earth. Magma formation takes place. Magma formation takes place in asthenosphere. It is the birthplace of all endogenic forces. It is the birthplace of almost all endogenic forces. All endogenic forces. The average density of asthenosphere is 3.5 gram per cc with average temperature 900 degree centigrade to 1200 degree centigrade. The limit of asthenosphere is up to 400 kilometer depth. 400 kilometer depth. Is it okay? 400 kilometer depth. Some area in asthenosphere, change the paragraph and write, some area in asthenosphere is having enormously high temperature. Enormously high temperature. Of the range 2000 to 2200 degree centigrade. 2000 to 2200 degree centigrade. These areas are referred as hot spots. These areas are referred as hot spot or mental plume. Mental plume explained by explained by James Tuzo Wilson in the year 1963. James Tuzo Wilson in the year 1963. These hotspots are just above the conducting rock of mantle that conducts heat from outer core to asthenosphere, from outer core to asthenosphere. Outer core to asthenosphere. When this heat reaches up to the upper layer, of upper mantle, melting of mantle rocks takes place. Melting of mantle rocks take place, and there is formation of, or there is pluming of magma, This is called as mantle plumes. ठीक है. अब आइए ये डिसकंटिन्यूटी, मोहो डिसकंटिन्यूटी. सो मोहोरविक्स आगे लिख लीजिए. चेंज. हाँ, क्या हो, टाइम हो गया. ओहो, 5 मिनट और लगेगा. क्या दूर जाना है? कितना? शादीपुर तो बहुत दूर. अच्छा ठीक है, तुम लोगों के पास वाहन, कोई बात नहीं, कल लिखा देंगे. ठीक है, 2 मिनट लगता, मैं बता देता हूं. बाकी कोर आउटर कोर आप जानते ही हो. ये लिख लो, मोहोरविसिक डिसकंटिन्यूटी, मोहो डिसकंटिन्यूटी. It is present between crust and mantle. ठीक है, फिर लिख लो, रेपिटी लिख चुके हो. ये गुटेनबर्ग डिसकंटिन्यूटी, present between outer core and lower crust and lower mantle. And last one, that is Lehman discontinuity in between outer core and inner core. Baki outer core, churning of outer core, electromagnetic induction already done, density लिख दिया है, temperature लिख दिया है. So from my side, interior of earth is done. Do read and improve your understanding, and then try to solve the PYQs. Thank you very much. कोई बात